Hello folks, I'm recording this video to show you how to do problem 9 from section 2.7, which as you recall I messed up in class, and it was a calculator mistake, but anyway, it was a mistake. So let's get this problem done. So this is the formula that represents the jump of somebody, of a rock, represents a rock, the altitude of a rock that's thrown up, straight up on Mars. So here's how this goes. As you recall, for part A, velocity is the derivative of h of a displacement, so will be in this case h prime of t, and this represents velocity for all numbers t, and it's 15 minus 1.86 times 2t, which ends up being, and let's write a nice formula, ends up being 15 minus, so I said 3.72t. All right, so this is the formula for velocity. Now, if you want h prime of 2, which is velocity after 2 seconds, you have to plug in 2. So that's 15 minus 3.72 times 2. And this is the exact formula that we found in class last time. I'm going to show you the class work here. So this is what we found in class, and that turned out to be 7.56 meters per second. So that was correct. All right, so this is part 1. Now for part 2, I did a little bit of extra work, because without preliminary work you could make mistakes. And here's what he says. So he says to find the velocity when the rock reaches 25 meters in height. So that means that we have to find out at what time we reach 25 meters high. So we have to solve the equation 25, which is the height that you want to reach, equals, and this is the formula for the altitude. So it's 15t minus 1.86 t squared. And I said in class that you could simply move 25 to the other side, or move these things to the other side and make a quadratic equation. So you can say here the quadratic equation is 1.86 t squared minus 15t plus 25 is equal to 0. And with this quadratic equation here, we can solve the quadratic equation with a formula. And now before I do so, though, let me point out that you can do the exact same thing. You can solve this thing without the formula. But the quadratic formula, I'm going to do the quadratic formula, and I'll show you how to do that with decimals. So t will be, and the quadratic formula says negative b, which is 15 in my case, plus or minus square root of 15 squared minus 4 times 186 times 25. All right, and this is not a terribly complicated calculation. Divided by 2 times 1.86. This is not a terribly complicated calculation, but this is where I made a mistake last time, and I'm going to show you how this is done in decimals. So this is decimals over here. I set up the equation exactly like we would do. Remember that decimals has a problem recognizing variables, so I said 25 equals 15x minus 1.86, and if you look, it plots the solutions of that equation over here. So one of them is this one, 2.353, and the other one is 5.71. So let me put both of them on the screen. So these are the solutions. So I can just copy these solutions. 2.353. So there's two of them. One of them is 2.353 seconds, right? Remember, this is time. And the other one is 2.711, something like that. So let me double check that I got the correct. No, 5.711. Sorry about that. So let's erase here quickly. So let's erase this thing. So it's 5. Again, 5.711. 5.711. There we go. So that's seconds. So this is when the rock goes up and it reaches 25 meters. This is when it comes down, so it goes up more and then it comes down after 5.711 seconds. All right, and when you do that, then you find the solution. So now let me show you how to find these solutions with Desmos. So I'm gonna pull here Desmos. This is the equation, so I calculated, you don't need this thing here, so I calculated the solution. Again, I did a little bit of work underneath here, so let me redo that. So so the solution would be the one that I put on the paper, 15 minus, if you want 15 squared here, minus 4 times 25, it was times 1.86, and you will see that Desmos gives you exactly what you need there. So so this is one of oops, what did I get here wrong? So all right, folks, so 1 second. So 4 times, oops, nope, got something wrong here. So 4 times 25. So let me just double check. I have a correct formula for, yep, that's 425 times 186. All right, so 1 second. So this is the formula, and there we go. So we got 2.353, which is the one here. So so that's where you get one of them. The other solution is the exact same way. You do plus here instead of minus and get 5.711, which is the second solution. And right now, if you want, you can calculate because you have a formula for velocity. So the velocity formula, let me point out here, is this one. 25 equals 15t minus 1.86t squared. So that's it's already given here on the screen, the formula for not this one here. So this is the velocity, and all you have to do is to say velocity at t equal 2.353 seconds. Velocity is 15 minus 3.72 times 2.353, and that is what the velocity is, and I calculated that with Desmos, and that came up to be okay, so 5.3, I forgot to put a 3 here, so there we go, I was deleting stuff there. So it turns out to be 6.2468, something like that. And for the other one, when the velocity is when the time is 5.71, velocity is so velocity at t equals 5.711 seconds. Velocity is 15 minus 3.72 times 5.711, and these numbers over here are the following, so they are 6.246 and 6.244, approximately the same, just with negative numbers. So so what happens there when, folks, when the rock goes up and when it comes down, it will end up coming with the same velocity through the same point of the same altitude, and one of them will be positive, the other one will be negative. So these are the results. So approximately 6.25, I think, would be both up and down. So over here you will get approximately 6.25 approximately, and then over here you will get negative 6.25 because you know, it's when the rock comes down. So velocity is against the sense that I decided to be positive. So the positive direction would be going up. So because it comes down, it comes with this speed. So so this is the answer to my problem. All right, thanks for watching here. So these are the answers, folks, this here. Thanks for watching. And again, I apologize for the mistake that we made in class. I hope this clears up the situation there. All right, let me stop recording here. Okay. Okay.